In this video, we are going to look at our pond design in relation to our highway. Now, when you're driving up and down the highway, Deerfoot Trail, Stony Trail, any major highway, you will see water storage ponds placed usually in interchanges along the edge of the road and anywhere there's space that the highway hasn't been built in and you don't want to build any buildings, there will be a water storage pond there. Now, the point of this pond is to get water off of the highway. Get it away from vehicles. We don't want vehicles hydroplaning. We don't want water stored on the highway itself. We want to get it to the medians and to the outside of the highway. This is for safety. Now, in the city of Calgary, we're pretty close to the city here. They use a specific number for their water storage. So when it rains, they'll say 70 liters per second, 90 liters per second, etc. And that's the number that they will use for their water. This is times by the area of the land. However, because this is a provincial highway, we're going to follow the Government of Canada rainfall design standards. But before we do that, we need to figure out where our pond is going to be. So we have to figure out our pond location. So I'm going to take a look at my profile here and notice where there's low points. Starting over here, there's really no low point except down at the south end, or at the east end here of the profile, which is the south end of my highway way down here. And this drains off into a creek, so you don't need to build a pond there. However, right in the middle in this location, I have a low point right in here at station 2,967, so we'll say 3,000. Now we need to figure out if we can fit a pond there. So I'm going to come down here, down to station 3000. I've got my alignment labels on, so I find 3000. And let's turn the air photo on. So I'm going to type geomap, hit on, hit aerial, and yes, I want to use this data. And hopefully it loads the map. Okay, there we go. So I'm going to zoom out a little bit, and I've designed my highway. It's coming through here. I got a low point at 3,000, which there is already a low point in the existing ground because we see a water storage pond here and a little bit of a water storage pond here. However, the one thing we do have to worry about is the subdivision to the east here. We can't build a pond so close to this that it takes out people's houses or encroaches on their backyards. We want to keep it a little bit away. So I got a bit of space in here, which at 3000 that works. And then I'm going to turn the air photo off now because it slows things down. And go back to my profile. So when I look at my profile, I see that I have a high point here and a high point here. And these just happen to be at station 2000 and station 4000. So I got a 2,000 meter section of road that is draining to one low point. Now we can go back to the profile and take a look at this, or sorry, the plan view. So from here, station 2000 to station 4000, this entire section of road will be draining to the low point. However, it's just not the water that's on the road. Anything that flows downhill will eventually make its way into the ditches along the road, travel down the ditches to the low point, pass under the road and into our pond. So we need to worry about any land that is draining towards our road. Now with a hand survey, this is a little bit easier. There's less points, but we're using a LiDAR surface here. So we are just going to guesstimate this, get a rough number, show you how to figure out the volume of a pond here. Again, with just a rough number, it's going to be accurate enough for what we need to design here. So I'm going to try and figure out how much land is flowing into the pond. Now I know that everything on this side slopes this direction over here. So from the left, the land slopes to the right. All this land is pretty much all paved. It's built up. There's residential houses, so that water's dealt with already by the city. So we have to worry about the water that's west of our road. Now I'm just going to draw a polyline Turn my snaps off so I don't snap into anything. So 3,000, all the water on this road. And again, I'm just going to do this very rough to get an area. So station 4,000 is the high point. And now we kind of have to guesstimate what part of this land is sloping towards the road. We could turn on slope arrows, but that's just some more unneeded information. I'm going to draw a polyline here, roughly, and trying to figure out, okay, this water will flow down here to the road is basically what I'm doing. I'm going to cut it off kind of around the high point here. Station 2000 is down here, so if I follow that, the water, say through here, more or less. Station 2000. Now, obviously, you would do this to a higher degree of accuracy, but for what we need, and for the example of this exercise, I'm just going to do it this way. So I've got my polyline drawn. Approximately this water is flowing into the pond. I'm going to check the area of it. So under properties, area 2.247 million square meters is flowing towards that pond. And again, if we cut it down a bit, maybe some of this water won't flow down there, etc. 2.1 million, 2.2 million. So we will go with 2.2 million square meters of water. So get a calculator open and just write that down so we remember that. So now that we have our area, we know where the water is going to flow, where the pond will be placed. We need to figure out how much rain is falling. So again, the City of Calgary does a 70, 80, 90 liters per second per hectare. So we could figure out that based on the city requirements, or we could do the Government of Canada requirements. So I will put a link to the Government of Canada's FTP site. It's just a Google Drive where this is located in. You can download it if you want to take a look at it. It's also on D2L. It's called the IDF Google app. So when you get it downloaded and unzipped, there's a number of folders. We'll just leave those all alone, and we'll click on the IDF station locator. When this loads, just ignore the warning. And we see here Canada with a bunch of numbers. Now, if we zoom in, the numbers will change because it's trying to display how many rainfall collection stations are near where the numbers are. So there's 59 within Alberta, within this area, 103 down at the coast of Vancouver, but we'll zoom in towards Calgary. Now, as we zoom in, we see Lacombe, Red Deer, Rocky Mountain House, etc., Kananaskis, but we have one in Calgary itself, and it's at the airport. So if we're doing work in Calgary, we'll use data from Calgary. So I'm going to click on the little storm cloud, and Calgary International Airport has been monitoring data from 1947 to 2009. This is a little bit outdated, but I'm not sure if they have an updated version. Then we have some links at the bottom, IDF curves, return levels, trends, but what we want to look at is the IDF table. So go ahead and click on the IDF table, and it will open up basically a notepad document showing every year from 1947 up to 2009 how much rain was received. In 1947, for example, a 5-minute storm dropped 4.6 millimeters of rain, a 24-hour storm dropped 28.7. However, each year is going to be different, and this is not the part of the table we want to look at, but this just shows you that data was collected. We'll scroll down to the Table 2A, return period rainfall amounts. So we have a duration at the top, duration down the left, 5, 10, 15, 30, all the way up to 24-hour storm. And we have a 1 and 2, 5, 10, 50, 100-year storm. So they've taken the data and they've come out with some numbers of how much rain is expected to fall in, say, a 1 in 100-year 24-hour storm. We're at the 94.4 millimeters, which is almost 10 centimeters of rain. Now, being that this is the biggest number on the table, we want to try and design for a 1 in 100-year 24-hour storm when we're designing this pond along the highway. Most of the City of Calgary will design to a 1 in 5 year storm. It's almost half the amount of rain falling in 24 hours. So if we do our pond, we're going to try and design for this 1 in 100 year storm. But keep in mind the city will only design to a 1 in 5 when they're doing work within the city. So we will remember 94.4 millimeters of rain, and we have to convert that to meters. That's all we need from this spreadsheet itself and even the Government of Canada station locator. So we'll just close those down and go back to Civil 3D. So we got our 2.2 million square meters. We have our 94.4 millimeters of rain. So we're going to take the 2.2 million square meters and we're going to times it by the 94.4, but we're going to put that in meters. So we're going to take the 2.2 million meters and times it by 0.0944. And we'll hit enter. And we get 207,680. Now this would be the amount of water we need to store if our entire section of land here was paved, or the porosity of the material was 0, so that means no water would soak in. Now different materials have a different level of porosity, meaning grass and gravel and dirt will allow more water to soak in, therefore not having to deal with it or pond, than say asphalt and cement and paved areas, buildings, clay, compacted clay, etc. So again, we'll just quickly turn the geomap back on just to see what our ground is composed of. Now, just taking a quick look, the majority of this is grassy area, farmers' fields, dirt, areas where there's plants and the vegetation can drink up most of the water. So this helps us when we're designing our pond. Basically, it means we don't need as big of an area for a pond than say if this was all concrete. So turning the geomap off, back to the calculator. Now, if the entire area was paved, we would need to be able to store 207,000 cubic meters of water. But being that it's grass and approximately 60% of the liquid will soak in, so that means we'd have to deal with 40% of this. We're going to times this by 0.4. And we get 83,072 cubic meters. So after all the calculations, you're given a cubic meter number. We have to store approximately 83,000 cubic meters of water in our pond. Using this number, we can come up with an approximate size of the pond. So just doing some simple math and knowing the City of Calgary standards, which we'll talk about in a second, I'm going to say if we go 100 meters wide by 300 meters long, we can store 30,000 square meters. Given the pond 2 meters deep, we'll only be able to store about 60,000. So again, play around with some numbers. Try not to have the pond too deep. Don't have it too shallow, etc. Find a nice happy medium. If we times 100 by 350, times that by 2, that gives us 70,000. Again, it's all going to depend on the space, the area. I've got an approximate shape here. It's 100 by 350, I believe. Just measure the distance between these two. 350 meters. Now, I've marked this out tentatively so I know where to place the pond. But I'm going to go with 100 by 350, and we're going to make it 2.5 meters deep, and that should account for our 83,000 cubic meters that we need to store. Now, I'm going to draw a rectangle based on the parameters that I've defined. You may have your air photo on right now to locate this. That's perfectly fine, but I've done it with just some points here. I'm going to draw a rectangle that is a dimension of 100 by 350. And then I'm going to rotate it based on my points here. Oh, sorry, I should have rotated it first. 100 by 350. And then I'm going to accept that. So you may have to put your rectangle in and rotate it a little bit. Try and align it with the highway, align it between the houses. Wherever you put your pond, you're going to have to take a look. Use some critical thinking as well. Will a pond fit here? Will a pond not fit here? Am I going to have to put the pond down here? Am I going to have to put it up a little bit higher? Again, we can adjust the location a little bit. But this is the spot where my pond is going to go. Now, in the real world, we would have to take this a couple steps further. We'd have to design a ditch from our highway to the pond. We'd have to design an outlet from a ditch, an inlet into the pond. It adds 2 or 3 or 4 more sites, more steps, more complexity that we are not going to worry about for this. We're going to simply worry about getting a pond placed into our drawing. And we're going to have the 4 sites. We're going to have 4 or 5 surfaces additional just to try and size this properly. Or design this properly, I mean. So the first feature line the first polyline I've drawn here is going to be my pond floor. Now we're going to start by making some sites. So I'm going to right click on sites and select new. The first site will be called Pond Floor, and I'll hit OK. And you might as well make all your sites now. Pond Berm, Pond Sump, and then finally Pond Forebay. And we'll talk about what all these are as we go through this. Now I have 4 sites here. If we were to do a pond inlet or a ditch outlet, we'd have to have another site for the outlet of the ditch. If we were to do a ditch, we'd have to have another site for a ditch itself. So we have 2 additional sites. Inlet into the pond, we'd have to have 3 sites. And then an inlet from the forebay into the pond, that'd be 4 additional sites, which is 4 additional grading objects, which gives you guys more things to possibly corrupt your drawing if proper procedures are not followed. So we're going to stick with these 4 to make things easier. Now, the first thing I'm going to do is under grading, I want to create a feature line from my polyline. So select your lines, arcs, polylines. I'm going to select this one. I'm going to hit enter. Remember to put these on the correct sites. This is my pond floor. And again, we have a number of colors here. I'm just going to, as I build things, I'm going to make them different colors so we can differentiate between all the feature lines because we are stacking them all up on top of each other. It's going to the proper layer. I want to erase existing entities. Again, you don't need to select this if you don't want to. But the one thing I do want to do from this dialog box is assign elevations. If you forget to click this, it's not a big deal. We can do it from another window, but we'll just do it from here. So I'm going to hit OK. And under the Assign Elevations dialog box, I want to pull elevations from my existing ground, the City of Calgary here. I do not want to select this dialog box because what this is going to do is every time your feature line crosses a triangle in your surface, it is going to put another point into your surface or into your feature line. So we're going to have a point every meter in our feature line. It's going to slow our Civil 3D down. It's possibly going to cause it to crash because we'll be grading off this in a few moments. So we'll just leave that deselected. And then I'm going to hit OK. My polyline has disappeared and we're now left with a yellow feature line. So I'm going to select this and I'm going to go into my elevation editor. So select it, right click elevation editor, which brings up my panorama window. Let's move it over here. Now what this panorama window does is shows you the elevations that are in this feature line. If I click on the first one, my first point is down here, 0 is here, my second point is here, my third point is up here, my fourth point is up here. Now if yours are in different locations, that's perfectly okay. Just tweak the steps based on what you have. Your 450 may very well be the first point. Then this will be 100. This would be 450, or sorry, 450 is down here. 550, 900, back down to 0, 100, etc. So just pay attention to what you're doing. Now I'm going to look at the elevations of the existing ground. I'm going to find out where the low point of my pond needs to be. We have 1,116 down here, 1,116 up here, 1,121 here, and 1,116 here. So using some critical thinking, the bottom of the pond, the lowest point of the pond needs to be at the south end here. So that is where I'm going to make my low point of my pond. Now I'm going to just take the lowest one, 1116.417. I'm going to set this one to 1116.417. Try and keep a flat plane down there, which makes this a grade of 0. Now grading to the north here, I want to grade ahead at, we'll do 1%. See how high that gets us. So we're at 1119, which is about 2 meters below existing ground. I'm going to grade to the left at 0%, and you notice the grade ahead from here to here is minus 1%. Now we have a grade back and a grade ahead column. These two can get very confusing because if you start playing with the grade back, it's going to grade backwards along the feature line. You're going to end up changing this point. If you grade ahead, it's going to grade from here to here. You'll end up changing this point. Now that all depends on the direction of your feature line. Yours may be going backwards, and again, just reverse those. I'm just going to hide the grade back column as it's just easier right now to just grade ahead. So we currently have a feature line that is sitting on the existing ground over here and is slightly under the existing ground here and is above the existing ground over here. So what I'm going to do is I'm going to take this entire feature line, I'm going to drop it 1.5 meters, 2 meters to establish the bottom of my pond. Maybe we'll go 1.5 meters for now. So I'm going to click this button here. I'm going to type 1.5. I'm going to select 0. I'm going to select 900. I'm going to highlight all those. And I'm going to drop this entire feature line 1.5 meters. And if you watch the elevation, it's gone from 1116.4 to 1114.9. So my entire pond floor is underground now. And this is the way you want to build them. You don't really want to try and build your floor above ground because if the berm washes away, it's going to cause a big issue. So I've got my pond floor. I'm going to make a surface now to see what it looks like. So I'm going to right click, create surface. I'm going to type pond floor and hit enter. I'm going to select my feature line, right click, add to surface as a break line, select my pond floor, hit OK. Again, you can name these if you want for a description, pond floor. It's going to help you not be confused. Type, we'll just leave standard. Mid-ordinate distance, this only applies when there's curves, and we'll leave that selected. We'll hit OK. And our surface has now updated. I'm going to freeze off my existing ground just so we can see this a little bit better. So what this surface is telling me is the pond floor slopes from here. This is the high point, and a flat plane all the way down to here. So everything from here flows down. However, we want to establish sort of a V-shaped pond floor. So if you imagine opening a book partially and there's a V-shaped, we almost want to define that as our surface. I'm going to rebuild automatic for this. Again, be very careful with this, with the rebuild automatic, as if you have too many things updating, it could possibly cause issues. But for this exercise and make it quicker for me, I'm going to rebuild automatic. So I'm going to right click elevation editor and look at these elevations again. Now there's a couple ways of doing this, adding additional points to this feature line so we can modify it. There's this button here, insert elevation point, which will create a point in your feature line that you can only move vertically up and down. You couldn't move it horizontally. This one will work. Along with, under grading, edit feature line geometry, we can insert PIs, which will add these triangles in, which will add a point that you can move vertically, horizontally, all X, Y, Z directions. So either one will work. We're going to keep it simple and just use the green dots here. So insert elevation points. I'm going to zoom in. I'm going to select the midpoint at the south end. Hit OK. I'm going to add another one in. Midpoint of the north end. Hit OK. And then I'm going to add in a few along the sides as well, due to this being 350 meters and Civil 3D trying to model triangles and possibly not being able to do it. So again, midpoint We'll hit OK. I'm gonna add one in the midpoint up here now. So these ones are a couple hundred or 100 meters apart, 150 meters apart, give or take. Midpoint here, and do the same on the other side. So once we have those 8 additional points added, we can go and start grading our feature line to look more like an open book. So as you see, those circles are now included in this window. We have triangles and circles. Triangles are the ones you can move X, Y, Z. Circles are the ones you can move in the Z value. So starting with the triangle, 0, 0, or station 0 in my case, the first circle's right here. What I want to do is I want to grade ahead at -2%. And then grade this one back up at 2%. I know it was almost 2 to begin with. 1%, 1%, 1%, 1% is fine. I want 1% to the top. And then when we get to the top, I want to go -2 down and 2 back up. And then -1 down here. However, our triangles are all messed up. Now this is because Civil 3D is trying to connect the closest triangles. So to keep this simple, I'm going to draw, a 3D polyline. I'm going to snap to the end point here. And then I'm going to snap to the end point here. I am then going to turn this into a feature line. So grading, create feature lines from objects, pond floor. I want it yellow. I'm not going to assign the elevations because a 3D polyline will pick that up. I put it on the same site because these ones are all regarding the pond floor and I want them to function together. I'm going to add to my surface as a break line, pond floor, and hit OK. And OK again. Again, you could name the description if you want. I probably should have. That fixes this now. And if we object viewer this, you can see how it slopes to the middle. It's a little hard to see because I don't have my surface exaggerated now. So it slopes down to the middle, slopes back up. It makes almost a sloped open book page. I'm just going to quickly save my drawing here. And then we'll continue on with the next part. So we need the pond floor to start defining the pond berm. There's a couple ways of doing this. We could start with a 3D or a polyline again, offset, or we could just use the feature line and quickly move it to the new site before it can cause problems. So I'm going to take my feature line, I'm going to type in stepped offset. Or sorry, that doesn't work anymore, offset feature. I want to offset this 1.5 meters, and I'll explain why in a second. I want to offset it to the inside, and I want an elevation difference right now of 2.5 meters. Now, when we build the pond floor, we need to include it inside what will be our pond berm so we can target things properly. And the top of the berm I want 3 meters wide, so I've gone 1.5 meters on the inside, and I'll do 1.5 meters on the outside. But we'll do the 1.5 meters slightly different. I'm going to now take this feature line, right click, move to site, because it is seeing this feature line. It might cause some issues here. This is a pond berm. So I want to make the destination site pond berm and hit OK. And then I'm going to go into feature line properties and change the style to, we'll say, blue for our pond berm. Now generally the top of your pond berm is completely flat, same elevation. It won't have slopes, it won't have V's or anything. So I'm going to select that, right click elevation editor, and I'm going to select the elevation up here because I want it 2.5 meters deep here. We may have to tweak this. This is 1120.917. I'm going to make every elevation 1120.917 and hit enter. So we now have our feature line 1120.917. We're going to go up to grading, create grading now. Select our first button, set the grading group. We want to grade off our pond berm. And I named these the same, so create a grading group pond berm, hit OK. Set my target surface. I want to target my pond floor on the inside, we'll hit OK. These are just your grading layers, which are already set up. These are your grading criteria sets, and we have projection to distance, elevation, and surface. All three are different. This one is a projection to surface, which is already set to. And I want to slope 5 to 1 to surface. Now the City of Calgary wants specific slopes. They want a multi-tiered slope, 7 to 1 and then 5 to 1, or 5 to 1 and 7 to 1. However, that just adds another level of complexity. We're going to keep it simple and just do one slope here. However, you could chain a couple gradings together to achieve the desired result. This will let you create a new grading criteria set. This will create grading itself. This will allow you to edit it, delete it, change the grading group if you have to. Tools and surfaces, some grading editor windows, elevation editor, grading group properties, and grading properties, and finally a hidey arrow. So if we click that, we can see what this 5 to 1 is doing. It's targeting the surface via cut fill. It's going to try and fill before it will cut. A slope of 5 to 1 up, and a slope of 5 to 1 down. And then overlap, it's going to hold the slope as the maximum and the styles it's using. Just to show you what that does. I'm going to click this arrow and create grading. I want to grade this blue feature line to the inside. I want to apply it to the entire length, and I want a cut slope of 5 to 1 and a fill slope of 5 to 1. Which gives me a blue line now, or a blue grading object now. I'm going to go ahead and create a second surface so I can see what this looks like. I'm going to name this Pond Berm. Leave it on the same style. Hit OK. I'm going to select this. I'm going to select this. So the outside feature line and the inside grading object line. Add to surface as a break line. Pond Berm, and hit OK. Pond berm insides, hit OK. Now, because of the triangle issue, Civil 3D has gone and not connected those two center points here. So we can do that manually. Or we could just add another feature line if we must, but I'm just going to connect them manually so we can see how I did do that. Under Pond Berm, I'm going to expand definition. I'm going to click on edits, add a line, which is adding a triangle basically from here, this low point, down to this low point. So as we see, that has now made the floor, or the berm floor, match the floor. Let's see how much water this holds really quickly, really simply with a command called stage storage. And we're just going to use this to see how much water it can hold all the way to the top of the pond, and maybe at a certain contour, because we don't want to fill the entire pond up. I'm going to define my basin from surface contours. I'll click define, and I'll zoom in, and I'll make sure to select the pond berm surface. Once I select that, it's going to come up with a giant table here with a bunch of numbers. This is the very bottom of my pond, 1114.3. If I scroll to the end, this is the very top of my pond, 1112.9. Now at the very top of my pond, I am holding 114,708 cubic meters of water. Whereas if you remember back, I need a mere 83,000 cubic meters of water. Now, like I said, we don't want to fill the entire pond up, but we also don't want to have a berm that's giant and massive between the elevation of the water and the elevation of the top of the berm. In this case, mine is about a meter difference here, where we want to go about, we'll say half a meter, so 500 millimeters. So I want my top of berm to actually be around 1112.4. Now this is easy to do. So we'll hit cancel. And again, you might have to play around with this a little bit, back and forth, raise your berm, lower your berm. It's going to be dependent on where you place your pond. I'm going to simply select my feature line here. This blue feature line. I'm going to right click, raise lower, and I'm going to drop it 0.6. Now the reason I'm dropping at 0.6 and not 0.5 is as the berm drops, as the top of the berm drops, this toe will move out, therefore giving me a little bit of extra space. In fact, I might even go 0.8. So the berm will get wider on the inside, can theoretically hold more water even though we're dropping it, if that makes any sense. So I'm going to drop at 0.8 and hit enter. My surface of my berm hasn't updated, but I'll set that to rebuild automatic. And as you can see, it's broken that triangle link in the middle that we had done. So under edits, I'm just going to remove it and re-add it. You should only have to do this a couple times until we get the volume of the pond. So I'm going to run stage storage again. Define my basin from surface contours and scroll down. I now hold 83,000 at about 1119.5. We'll say 0.6, that definitely holds it. 1112.1, it's a half a meter higher. So I have a half a meter between the top of my berm and my high water level now. We will remember 1119.6. That's an important number here we're going to have to pull out. So I'll just type it in my calculator here. So the next step, we're going to have to define the outside of the berm, which is where the berm will touch existing ground to make sure everything fits nicely. So I'm going to offset feature again. I'm going to offset 3 meters. However, I want this blue feature line to offset to the outside. And I want an elevation difference of 0. So this is going to define the top of my berm. Now I want to grade 5:1 to surface again. However, I want to change the surface to existing ground, City of Calgary. So this outside feature line, I want to target the existing ground. I'm going to create some grading from here, outside, apply to entire length, yes, 5:1, 5:1, and hit enter. This will take a few seconds, mainly because you're targeting a bunch of triangles now instead of a simple flat book-like surface. So once I have that outside feature line, I can take a look and see my highway lines here. Here's my daylight line on my highway. So the red line is my boundary, I'll just delete that. The green line is my daylight line. I can see I'm getting pretty close to my ditch daylight line, and even down here I'm starting to overlap into my highway itself. So that means I need to change the elevation of my pond. Now, hopefully that middle triangle sticks, but we'll see. I'm going to save my drawing first before I go and do this because I'm going to be moving a number of objects all at once. I want to drop everything the same amount. So this feature line, the inside feature line, and this feature line. So I've selected all 4 of my feature lines. I'm going to right click, raise lower, and I'm going to do this a very little bit at a time. I'm not going to type -5 meters right now because things may crash. I'm going to go -0.2, and I'll let it drop to 0.2 meters and make sure it's not interfering with my berm. However, it still is. So I'm going to go select those feature lines again. Not my surface. And I'm going to raise lower. I might try -0.4 this time. Again, little numbers. Don't go -2 meters, -1 meter. It's going to crash because you're trying to rebuild too much stuff at once. Still overlapping. Not my surface. Raise lower. We'll do -0.4 again, and hopefully that is sufficient here. No, still a little bit. select them all, right click, raise lower, and let's go minus 0.2. So in total, I've dropped it 1.2 meters. I wouldn't type 1.2 off the get-go because you could have crashing issues. And finally, geomap on, just to make, aerial, sorry, to make sure I haven't interfered with any of these houses. If you want to leave the geomap on, go for it. I'm purely turning it off because it slows Civil 3D down when I'm trying to design. So geomap off. And then we are going to take our two grading objects, so these very two outside feature lines, and explode them. I want to get grading objects out of my file. I don't want to leave them around after I have my design done. They are one of the most unstable objects in Civil 3D, and they can cause crashing. So I'm going to select these two feature line, or these two 3D polylines now. I'm going to grading, create feature lines from objects. I want them on my pond berm. I want EDD feature line blue to match. Erase existing entities, don't assign elevations, and hit OK. I'm now going to select these four feature lines, one of which is probably still in my pond berm surface. Right click, add to surface as a break line, pond berm, hit OK. It's already added, but that's okay. We'll go pond berm outside and inside and hit OK. Again, that has wrecked that triangle, so we are going to delete it and just quickly re-add it from here down to here. And then finally, I want to clean up the triangles on the outside of this, so I'm going to add a pond berm boundary, outer boundary, type outer, hit OK, select this, and we now have an outer boundary on our pond berm. Again, little things like this I would probably clean up, so we can go under grading, edit geometry, and delete some PIs. And I'm just going to delete a couple PIs in here to more or less even this out. Just a little artifact due to the surface itself and being LiDAR, where that looks a little bit more normal. And just clean things up. We will square these toes off in video 3 of the pond design. But for now, in this video, we've gone through how to size a pond, how to locate a pond, designing the pond floor, designing the pond berm, putting a boundary on it. And part 2 of the video we'll design a forebay and a pond sump down here. And then part 3 is cleaning this up and putting in a drawing and creating survey points.